Hello. Now we are going to talk about linear models. What is model? What is linear model? Why do we need it? Mathematics and econometrics, how they're related. And first of all, let's go over the first things first. Now that we know about data types and values, how to make them, store them, let's go over the datasets that are freely available within the base R package. To talk about everything that's in the base package, let's go to the package pane and see the libraries, the packages that we have. We have lots of packages here, but we are interested in two of them. One is mass package, which holds lots of datasets. You can either scroll and look for the packages that you're interested in, or you can search from the search menu, search pane, mass. So there is a mass, and let's go to the help page of mass. So what do we have here? Datasets, support for datasets, so that it holds lots of datasets within, and if you want, you can not download, but in order to use mass, you have to if you have installed the package, you can just mention library and mass and download it. But on the other hand, there is the most easiest way to bring in many datasets is through the datasets package library. Datasets package, as you see, there are two packages that is found while searching for datasets. But the difference between the mass and datasets is that when you use a mass package, you have to download the library, but when there is a need to look at the datasets package and go and choose some datasets within, there's no need to download the library. You just mention the name and it comes. For example, let's make an example. For example, the first thing, the ability, yes, it comes anyway. What is it? It is it's a list. It consists of three parts: covariances, centers, and number of observations. So it's a list with three components. There are many, for example, air miles. Let's look at the air miles datasets. There's a little thing, and let's go over some theory behind the econometrics and mathematics to learn get some idea about equations. So in equations, in mathematics, there are very many kinds of equations. There are differential equations, there are linear equations, there are logarithmic equations, I don't know, so many equations. But the first starting point in the equations chapter in the mathematics is linear equations. And in statistics, it's also the same. You start the modeling chapter in almost any course with linear analysis. So what is linear analysis? It is, as it comes from the name, linear analysis is about lines. For example, we can look at the line here. There is a straight line. Maybe I have not drawn it to scale, and it includes some ups and downs, but it's in the I wanted to make one line, something like this. And the equation of this looks like this: ax plus b. There is no exponential thing within this. And what is the aim of putting line within this equation? It is the aim of this is to predict the next y element from the x element. And there is, of course, there is some slope, there is the starting point, intercept, and other parameters of the equation. Let's get back to our R program. So, as I mentioned, there are lots of datasets within datasets package, but we will go over a big data frame. It's cars 93. For example, let's look for there's only cars as well. Let's look for available datasets. Cars 93. Yeah. Okay, we need to export. Mass datasets. Anyway, so let's bring our data in. Let's run this, and let's see what this data is about. Oh, maybe some parameters are not. Let's go see what is D1. It's a big data sets. There's so many there is a manufacturer column, model, type, minimum price, price, and so many. And let's see the summary of. So we get some statistics, summary statistics, with this function summary and the data which we have tied to the D1. Median, mean, quartile, maximum, these things. and we know that there are lots of columns. What is most important in cars? What does the most different, the eye-catching difference between the cars? It is picture, and which does not seen when you look at it is its price. Not everybody can afford to buy this car, but they can afford to buy some a little reasonable price car. So we want to see what is the price of car, but how can we predict it? We can use some parameters that are within the Cars 93 dataset, data frame. I have made a linear model. In doing this linear model, it is the price of a car is dependent on its horsepower. It's my first H0 is that there is horsepower, engines, and RPM columns do affect price, and also they are their beta zeros or A's are different than 0. So let's let's clear the screen with Ctrl L, and let's run this model. Okay, now we have our model in the environments, and we can bring the summary of this model with summary M1. Let's run this. Okay, so our formula is this: price is dependent on horsepower, engine size, and RPM. And there are some residuals. It's also important for statistics, but as it's our first introduction to the models video, we'll not go over this. Now let's look at the coefficients. So intercept, which is B, which doesn't have any parameter, is 1.11. Horsepower is 0.14. It is from solely the equation we get that there's a little correlation between it affects very little the price. Also engine size also has some effect, but it's very small, and RPM also has a negative effect. But it's better to look at the whole picture. But in order to see the whole picture, we have to look at the t values and f values. T value is about a t-test, and we look at the t-value and compare it with the student's t-test value and see if it's lower or higher. But better way is to see it through probabilities, and the probability here, for example, it's the intercept, it's 0.92, so it's not significant. In the real model there is no intercept. It means And second, horsepower. It is 102 times 10 to the power of minus 0x. It is significant, and it's significant even at 0.0 level, so it's very significant. So in the real model, horsepower there exists. Engine size, what about the engine size? We look at the probability p-value of the engine size, and we see that it's 0.97. So in the real model there is no engine size in the equation, in the formula. RPM, we look at the RPM and the p-value of it, so it's also insignificant. And adjusted R square, and R square, it's 60%, 62%. It fairly good explains the model. So horsepower explains price. There is some relation. And we look at the F statistics, that the whole model is a good fit or not. It's the beginning statistics is the p-value. We look at the p-value, it's 2.28 e to the power of minus 16. It's also a very small value. It's near zero, almost zero. So it is, the model is significant. It is a good fit model. And in this video we went over of bringing a data and looking at it, getting the summary of it, the quartile, median, some other summary statistics, descriptive statistics, and other things, also the models. Of course there are lots of models within statistics, mathematics, but we went over the first linear model, which is the starting point for understanding models in statistics and econometrics. Thank you very much. If you do like the videos and want to see the coming videos, please subscribe to my channel. I am going to upload interesting videos on statistics with R, and in the future with Python. It is very interesting to me, and I want to spread the knowledge. I want to be the one who spreads the knowledge about statistics, econometrics, and I think they need to be done through free softwares. If you also think this way, please subscribe to my channel. Thank you very much. It was a pleasure to talk about statistics and econometrics.